Hello dear students, welcome to Konar classes. Today we are going to discuss differential equations. So today is the first session, and in this session we are going to learn the 3 points. The first one is the introduction to differential equations. Then we will learn about the basic concepts, and finally we will see that how to find the order and degree of a differential equation. So let us start with the introduction. Dear students, if you recall that earlier we have learned about differentiation. What is differentiation? Suppose you have been given a function y equal to fx. Here x is an independent variable and y is a dependent variable and dependent on x. Now we have learned that how to find the differentiation of y, that is a dependent variable, with respect to x, the independent variable, and that we say as f dash x, and that is known as the differentiation. We have learned about integration as well. What is that? Suppose we are aware of that after differentiation whatever we are getting, that we are aware of. Means what? Suppose we have differentiated a function. We are not aware what is this function, but we know after differentiation what we get. Suppose we get gx. I repeat, dear students, that after differentiation of a function we get a function called gx, and gx is known to us, but we are not aware what is this function. Okay. Now to finding this function whose differentiation is gx is known as the integration. That means if we get a function here, suppose if we get a y, that finding this y, is known as the integration. So from here what we can write? So this implies we can write dy dx is equal to gx. Okay. This is known as a differential equation. Okay. We will learn in details after a few minutes. Now the differential equation has immense application in physics, chemistry, biology, sociology, anthropology, economics, etc. And that is why it is very important to know differential equations. So what we are going to learn, we are going to see that how to form a differential equation, how to find a solution to a differential equation, general solution, particular solution. We will see that how the differential equation can be solved of first order and first degree. That we'll see as time goes by, in not today's session, in some other sessions, and we will see some practical application of differential equation. Okay. Now let us understand about the as we are aware of the the fundamentals of the differential equation. So now let's understand about the basic concepts. Okay. Let us think about few equations, dear students. Okay. The first equation, so I can write down from my notebook. If you look into these equations, these are known to you, right? X square minus 3x plus 3 is equal to 0. If I write sin x plus cos x equal to 0. If I write x plus y is equal to 7, all these equations are you have worked on earlier. This is known as a quadratic equation. This is known as a trigonometric equation, and this is a linear equation with two variables x and y. Okay. Now in all these equations we see there are independent variable, dependent variable, and how to find the values of x and y we have learned. Now another form of equation I am going to write here, and let's see how it is. Okay. If we write an equation something like this, x dy dx plus y equal to 0. Suppose we write an equation something like this, and that equation contains what? This equation contains the independent variable x, the dependent variable y, and the differentiation of the dependent variable with respect to the independent variable. Now, a equation which contains the independent variable, dependent variable, and the differentiation of the dependent variable with respect to the independent variable, it could be of higher order also, is known as a differential equation. Means I can say something like this, that xy d2y dx2 plus dy dx power 3 plus 5 equal to 0. This is also a differential equation. Why it is a differential equation? Because it contains an independent variable x, the dependent variable y, and the differentiation of the dependent variable with respect to the independent variable. For example, here dy dx, first order differentiation. Here it is d2y dx2, second order differentiation of y with respect to x, and other terms are there. Here in this case a constant term. So this is a differential equation. Now, it may possible that there are many independent variables. Okay, so that is known as a differential equation, a generic definition. So what is the generic definition of a differential equation? It is an equation consisting of the derivatives of the dependent variable with respect to the independent variable or variables, okay, is known as a differential equation. Now, if we restrict the definition something like this, if an equation consisting of the derivative of the dependent variable with respect to only one independent variable, that differential equation is known as an ordinary differential equation. Okay, so in our entire discussion, okay, we are going to discuss only on ordinary differential equation. These all are ordinary differential equation. Why Because there is only one independent variable. These are the derivatives of the dependent variable with respect to only one independent variable. Okay, so that is called the ordinary differential equation. Now, dear students, what will happen if there are multiple independent variables and equation consisting on that? That is called the partial differential equation, which is not scope of our discussion. Okay, so I hope you got a very clear idea about the differential equation. Now, dear students, what we are going to discuss is the order and degree of a differential equation. So this is a differential equation, this is a differential equation. Okay, you can form an equation something like this, that x square into d3y dx3, okay, plus x into y into dy dx is equal to 7. That is also a differential equation. Okay, now we are going to discuss the order and degree of a differential equation. So these two are very important attributes of any differential equation, order and degree. Let us understand that what is order and degree of a differential equation. So let us take one by one example and explain you what is the order of a differential equation first, and after that I will explain what is the degree of a differential equation. So let me take some specific example and understand this thing. The first one, what I am going to take, dear students, is that suppose we have a differential equation that dy dx is equal to e power x. If we see that there is a differentiation of the dependent variable with respect to the independent variable x, so this is a differential equation. Now, what is the order of a differential equation? The order of a differential equation is the order of the highest order appeared in the differential equation. For example, in this case, what is the highest order appeared here? It is 1, because dy dx is the differentiation of y with respect to x, that is the first order. So its order is actually 1. Now let's take another example. For example, we take d2y dx2 plus y equal to 0. What is the order of this differential equation? Is 2. Why? Because 2 is the highest order of the differentiation, okay, of y with respect to x. That is why its order is 2. If we take another example, something like this, d3y dx3 plus x square into d2y dx2 power 3 is equal to 0. The order of this differential equation is 3. Why? Because third order is the highest order in this differential equation, because this is a third order differentiation, this is second order differentiation. As the third order is the highest order of differentiation appeared in this equation, we can say the order of this differential equation is 3. So if we write here, dear students, so what is the order? Okay, so this order is 1, this order is 2, this order is 3. Okay, dear students, so now we are going to discuss the degree of a differential equation, the second attribute of a differential equation. What is the degree of a differential equation? The degree of a differential equation is applicable only if the differential equation is such that where all the derivatives are in the polynomial expression. I repeat once more, dear students. The degree of a differential equation is applicable to those differential equations where the derivatives occurred as a polynomial expression. Okay? If it is not, then we cannot say the degree of the differential equation. We will see one by one. Now, if the derivatives are occurred in the polynomial, then what is the degree of the differential equation? The degree of the differential equation is the power, that is the positive integral index of the highest order derivatives as appeared in the differential equation. I repeat once more, dear students. So the degree of a differential equation is the power, that is the positive integral index of the highest order as appeared in the differential equation. For example, if we look into this particular differential equation, what is the degree? Degree is 1. Why? The first order derivative has the power 1, that is the highest one. So if we write here the degree, let's see, what is the degree? Degree here is 1. Now in this case, what is the degree? Degree is actually 1. Why? Because the highest order derivative is d2y dx2 and its power is 1. Nothing is there, that means power is 1, so its degree is 1. If we look into this one, this is a very classical one. If you see, what is the highest order derivative? Highest order derivative is d3y dx3, and what is the power? Power is 1. So its degree is 1. And note that there is a lesser order derivative is there, that is d2y dx2, its power is more than the power of d3y dx3, but we should not consider this one, we should consider this one. I repeat once more that what is the highest order derivative and what is the power of that? Nothing is mentioned, that means 1, that is why the degree is 1. Correct? Let us take one more example, okay? Few more examples, okay? So I can write it here. So if I write an equation something like this, that d3y dx3 plus 2 d2y dx2 complete whole square minus dy dx plus y equal to 0. What is the degree of this differential equation? Is 1. Why? Because the highest order derivative is 3, that is d3y dx3, and its power, that is the positive integral index, is 1. So what we can say? So its degree is 1, obviously. And what it is order? Order is 3. Okay, so we can write the order is 3. So this is the order sequence we are maintaining. Okay. This is the order sequence we are maintaining, and this is the degree is properly mentioned here. Now let's go to the next equation, is that dy dx whole square plus dy dx minus sin y is equal to 0. This is an interesting one. If you see that sin y, okay, if you expand sin y, that is not in the polynomial expression, okay, but we should not bother about this thing. As I said earlier, the differential equation should have been expressed as a polynomial expression of the derivatives, then only its degree is possible. So here it is that the same case. So what is the degree then? Degree will be, here it is 2. Why? Because what is the highest power? Both are first order, right? If I say its order is 1, its order is 1, but what is the degree? Degree is that the highest power is 2. Here the power is 2. Here the power is 1, 2 is more than 1, so we can say the degree of this differential equation is 2. Correct? Now let us take another example. So if we write the next one is that dy dx plus sin dy dx is equal to 0. This is not a differential equation in which the derivatives are expressed as the polynomial expression. So its degree is not defined, but it is having an order. What is the order? The 1, because the first order derivative appeared in this differential equation. So what we can say, its order is 1, but its degree is undefined. Okay, dear students. So what we learned? We learned is that it may possible that there exists differential equation whose order is defined but degree is not defined. And if both order and degree are defined for a differential equation, both has to be positive integer. Okay. So we have learned about the degree and order of a differential equation. So before we conclude, let me give you few examples. Okay, so you also do, please open your notebook and write along with me, and let's find the order and degree of this differential equation one by one. Okay. The first equation, dear students, so here it is. The first equation I am writing is that dy dx minus cos x equal to 0. What is the order of this differential equation? Order obviously 1, because this is 1 is the first order derivative occurred in this differential equation. Okay, so that is why order is 1. What is the degree? Degree is also 1, because the power of dy dx is 1. Now one thing you can notice that the expression cos x is not in polynomial expression, but we are not bothered about this thing. I repeat, as I said few times earlier, that the differential equation should be expressed in the polynomial expression on the derivatives, not on the variables. Okay, so that is why it is having a degree 1. Next one, dear students, is that xy d2y dx2 plus x dy dx whole square minus y dy dx is equal to 0. Let's see. So what is the highest order derivative? Highest order derivative is 2. So that's why its order is 2. And what is the degree? The highest order derivative is having power 1. So that is why its degree is 1. Correct, dear students? So now let's look into the next one. So y triple dash plus y double dash plus e to the power y dash, okay, equal to 0. By the way, What is y triple dash, y double dash and y dash? So I can tell you in brief about this thing is that if you see that y equal to fx, when we write, that what is y dash? Y dash is nothing but dy dx, that is f dash x, the first order differentiation. What is y double dash? Y double dash is the second order differentiation, d2y dx2, that is also written as f double dash x. In the similar manner, if we go for the y triple dash, that is equal to d3y dx3, that is equal to f triple dash x. Now dear students, in that way we cannot proceed much, because if this is a nth order derivative, how to write those nth dot? That is not possible, na? So how to write this thing? So dny dxn is written as yn. If you see something like y with subscript n, that means it is the nth order differentiation of y with respect to x. Okay, so now if we look into this one, what is the order? Order is 3, because third order differentiation appeared in this equation, so order is 3. But what is the degree? Degree is undefined. Why? Because e to the power y dash is not in polynomial expression on the derivative y dash. Okay, that is why its degree is undefined. Okay. So I hope you got a very clear idea about the introduction, the basic concept and the order and degree of a differential equation. In the next class, we will discuss the general and particular solution of differential equation. Till then, thank you very much. Bye.